Hi everyone, a pleasant day to you. In this video, I'll teach you how to make a simple stack and flow diagram using the Vensim PLE 8.2.0 software, which can be downloaded free online from the vensim.com website. So to make a stack and flow diagram, you need to have a causal loop diagram because from that model, from that diagram, you will transform that one into this SFD. So your basis to make this is the CLD. Okay, which I already discussed that one on my video on the causal loop diagram tutorial. So for this video, I will use the student population system example, which is our stock is the student population. Okay. Now in CLD, I use these commands here, and for this SFD, I will use more commands here near. Okay. And to start, okay, first we will go to our model settings. Our model settings allows us to set our time boundaries. If how long would we want our model to be simulated? Because through SFD, we could determine the behavior of our system, okay, for the future years. So for our student population, I'd like to know the student population, enrollment, and graduation for 5 years, for the next 5 years. So I'll start with 0. Then final time will be 5 because I want it 5 years. Time step will be 1 yearly. So I want to see the behavior of the system yearly. So let's have that one. Then the unit will be, the default is months, will change at 1 to years. And integration type, we'll just use the default year. Okay. And active initial relative absolute, we'll just use the default. Then okay. You cannot see changes on our screen yet. Those settings will be applied when we do the simulation. So to make a model, first we have this level command to make this stack. Then click that one, then we'll click our canvas or our screen. Let's type student population. So if this happens, you just drag or just adjust this, okay, to make your stock more presentable. Then actually you can also change the font style and size. You can use this move or size command to highlight student population. And if you want to change the color, say for example, I want that one to be blue, then it does not change. Okay, so that will be our student population. Now, this is our stock, and the stock is affected by our flow. So the flow for students population is our student enrollment. So this is the command for having or for adding flows into our stock. So we have rate. Since it is an inflow, we will click on our screen, then there will be a cloud coming out. Then since it is an inflow, it will be directed towards student population. Then you click that one. It wants us to type what's the element there. So that will be students enrolled. Okay. Then for our outflow, okay, it will be student who graduated. I click the student population here first. Since this is our stock, this will be now the source for our student graduation. So the cloud symbol will not appear here. So the arrow will be directed going outside because this is an outflow. And then you click, okay, it allows you to type the element. That will be students graduated. In this model, I'd like to know how many students are enrolled for the next 5 years, how many students graduated for the next 5 years. Okay, yearly, I want to know the data yearly for the next 5 years. How many students? So for making an SFD, you need to identify, okay, the units of your elements. Then, okay, there are only two flows, the inflow and the outflow, because this is our a simple model yet. Then no more flow, so I'll just escape to exit this command. Then a cloud remains. I'll just use this delete command here to delete. Okay. Then I want to align this, so I'll just use this move or size command to adjust. Okay. Notice that this arrow, okay, when I adjusted, it curved this way. So actually you can click on this you can click on these buttons to adjust your elements. Okay. Then students enrolled is affected by variable, a certain variable, let's say enrollment rate, okay, which may not be reflected in our causal loop diagram, because in SFD you can add variable, okay, here you can do the diagram concisely and more detailed. You can add variables here which were not presented in the CLD. Okay, you can do that as long as you know what will be the units, because later on you need to add or subtract the elements. Okay, you can combine, integrate, okay, or differentiate the elements. So you need to have a uniform unit, because student population as our stock is affected by the inflow and outflow. So what will be the value of our student population if more will be added, okay, or more will be subtracted? Okay, that's a concept. Then, since there is a variable for students enrolled, and that will be enrollment rate, meaning the percentage of our students enrolled yearly, and our graduation rate. Sorry. Okay. So this influence students enrollment. So this will be the command for the causality symbol. Then click and adjust to make a curve. Then graduation rate as positive causality, positive impact to students graduated. Okay. Students enrolled will influence student population. If there are more students enrolled, there will be more student population. If there are more student population, it will feed back to students enrolled. Okay, so indicate that one with that arrow. And then if there are more students today, okay, there are more student population, it will lead to more graduation in the future. Okay, and adjust again. Okay, so this will now be our simple SFT model. And after making the diagram, we will input the equation because we will solve na, we will simulate. You need to input equation or values of our elements, of our variables. So our variables here, those that may vary, those that may go up and down and may influence the flows, the inflow and outflow of our stock. So enrollment rate, when you click the equation command, there will be a function of x symbol here. When you click that one, okay, it allows you to edit. So the equation for enrollment rate, okay, let's say you already determined the enrollment rate. Say for example, in a certain school, there is a 20% increase of enrollments. We'll just use 0.20. Then, since that is percentage, so we may the units percentage per year. Okay. So notice that if you already inputted the equation, the black background will be gone. And graduation rate, usually in our school, we have more enrollment because we have first year to fourth year students. Then every year only those fourth year will graduate. So it is lesser than our enrollment. So we have 10% of our student population. Then units will be percentage per year. Okay. So this is now good. Then we have student population. Okay. The Vensim software automatically has this equation. Okay, because that is the stock. Okay. The software already defined that the stock is the accumulation of the flows coming in it and the outflow going out from it. So it's just simply the integration of students enrolled minus the students graduated. But it needs to have the initial value, meaning if you want to study a certain system, you need to identify the existing, okay, the existing, let's say, existing student population, because SFD is a useful tool in simulating. So when you do simulation or forecasting, okay, you need to have a history of your system, a history on your, you need to retrieve a data so that that will be your basis, okay, for um, future use, okay. So let's say you have, let's estimate, okay, let's assume that we have a 3-year data, 5-year data, then we'll get the average of those data from the previous years for our initial value. So let's say we have an average of 1,000 students. Okay, we are a small university. We have an average of 1,000 students enrolled yearly from first year to fourth year. So that will be our initial value. And students enrolled. So for the past 3 years, there is an estimate of 20% increase in enrollment. So enrollment rate, okay, that is 20%, okay, that's an estimate, then it will be multiplied to our student population because here students enrolled, the units per student enrolled is the number of students. Okay, so just input here number of students. or you just can put students because it's already the units. So let's say 200 students, 100 students. So that will be student population, or it can be exchanged. It will be enrollment rate times student population. Then okay. Then for graduation, that will be student rate times student population. And okay. Now all the black backgrounds are gone. So we're good to go now. Then we go to simulate. Okay. Data set current already exists. Do you want to override it? It means that actually when you click this command, okay, it allows you to save another file, mean a VDF file, meaning a Vensim data file, okay, for your simulated data. Since the current is the default name for the folder and I already used that one, okay, we will not override it. We'll make another file name. So let's say student population. Then the extension is VDF, so meaning Vensim data file. It is the file extension for the simulated SFD example. Okay, there you go. The default name changed to student population file name. So simulation results file name. Okay, so you click that one again. It says that student population already exists. So that is our file name. Just say yes. So as you can see, nothing happens to this diagram, to our drawing, nothing happens. But if you look at the graph, okay, it shows the summary of our simulated result. Okay, this will now be the result of our diagram. So we want to see how many students are there for the next 5 years. So students graduated will be increasing. So we inputted enrollment, so graduation rate of 10%. So 10% of the population is 100. So initially we have 100. Then it will increase yearly because we also had a consistent increase of 10%. Then we want to know that is students graduated. You can also adjust. Okay, let's adjust that one. Drag. Then we have students enrolled. Okay, let's graph our students enrolled. So it is increasing also. Okay, when you maximize our screen, it details or it divides our graph into smaller calibrations. Then if you will adjust that size, it will just give us this data yearly. So initially we have 200 because we inputted 20% enrollment rate, then multiplied to population is 1,000, which is 1,000, and we have 200. Then we have a data of 20% enrollment rate and no other variable that affects enrollment rate. So it's just steady increasing. So for the next 5 years, it is exponentially growing. Then If you will graph enrollment rate, it is just steady, it is constant, okay, because nothing affects enrollment rate. Then we have student population. What do you think will be our student population? Okay, so initially we inputted 1,000 students, average of 1,000 students. So in the next 5 years, we will have an increasing number of students. So in the next year, since we have an increase of 200, then subtracted by 100, so maybe this will become 1, 2, minus 1, 1, 1. Okay, 1,100, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay, this one. This is, if you will maximize, okay, this is 1,100, 1,200. It's not really exact if you will see at the graph, but it's approximately. Okay, so it's how you interpret the graph. Actually, you can use this command, cos strip. You can have a graph, a total graph. You'll not click one by one. So you can see now, you can compare the result. All are increasing. Okay, students graduated, students enrolled, and as well as student population. So this is the result of our simulation. Okay, now you can, through SFD, you can see the behavior of student population, students graduated, student enrollment for the next 5 years. So if that case happens, okay, the administration will now have the idea on its number of students to be catered. And so it has the ability to plan and become ready, okay, for catering those needs of that students, okay, because they already forecasted and see the result for the next 5 years. Okay, always take note that you need to have a data on the existing and the previous years of your system, okay, that you want to study. Do not forget to save your work as always. Okay, save that one. Save that one into student population. Okay, model file and save. And we're good now, okay? So I hope you learn how to make a simple SFD. That would be all for this video. Thank you so much for watching and bye.